that does anything, I don't know.
So, yes, welcome to the EmpathyBytes VR Subteam Fall 2024 Unity Workshop 1. It's going to be pretty free-flowing. It's going to be pretty introductory because there's people here who don't really have experience with Unity. So for you guys, I'm going to go over the basics of the Unity interface and where everything is in the project, kind of how to look for where things live and exist, and I can go a little bit more into the basics of like where things are in the meta interaction SDK, specifically how that works, and then at the end we'll try to build the project on Denzel's Lended Quest Pro. I have a cable here that I know works, but make sure the project works because I'm using remote desktop right now, so I'll have to use your computer to build it to the headset and see if it works.
Yeah, I'm opening it right now.
Cool. And you guys are welcome to follow along in your project or just pay attention. I'd encourage you to take notes about where things are, but again, it's recorded. And please stop me at any time if you have questions, because I'm not just like workshopping to hear myself talk. I want to like help you if you have any clarification, or if you want me to go more in depth into a specific thing, any questions at all, stop me. Cool. And what's your name? Feben. Cool. Yeah. Feben, Hebe, Shrenik, Denzel, and Shashank. Awesome. So, this is Unity. This is the default layout of it. So in the center we have this game view. You can navigate it by holding right click on your mouse and move your camera around, and you can use WASD to move forward and back like most video games keyboard. You can go E to go up, and you can go Q to go down. And that's the basics of that. You can click on anything in the scene, and it will highlight it in the hierarchy. And you can click multiple times. If you don't select the right thing, you can click the same spot in multiple times, and it will cycle through all of the objects in the scene that are at that location, I guess. So if you can see well, on the left here, this is the hierarchy. So I guess to backtrack a little bit. So everything. Oh shit. Why is OBS open? Okay. Everything that exists in your project is in this assets folder. So if we navigate here, so if I go to GitHub and I go view, repository view in Explorer, our whole project is this folder. So we have everything you see here is what you see. That is not correct. Is what you see in the Unity project. Unity. Sweet. So everything that a scene will reference is in these folders, and it's good to organize them. So we have a materials folder. We have a models folder, which has 3D models. You can organize them in different ways, but here we have each folder contains a 3D model, and then the textures and materials that go with that 3D model. So there's a specific workflow that you have to do to import a model into Unity correctly from Blender and have the texture work properly without you having to do a bunch of extra work. And that's documented in my older Blender workshop. But yes, Oculus folder provided by Oculus plugins. Prefabs are basically any object in a scene that you want to use multiple times. Maybe it'll be better to explain that later. But so everything is in here, and then we have scenes. So scenes are the main other aspect of Unity. So I have this main menu scene. If I double click on the freshman dorm scene, I'm now in the freshman dorm scene, and nothing, no objects, no assets are stored in a scene. They're only referenced in a scene. So all a scene is a text file that tells you every asset in the scene, all of the components and logic that they use and where they're located. So you can actually like open a scene file, scenes, where's the scenes? Oh, assets, scenes, and if I right click this and like open with, I don't know if it'll let me, oh, edit in Notepad, it's literally just a giant text file. So when you guys work collaboratively, you don't want to work on the same scene at the same time because you're editing the same text file and it's not really human readable, so it's really difficult to diff the differences between two if you both have one scene checked out at the same time. So I usually recommend that you coordinate with people to work. Oh, hey Eric. I was just going over the basics of Unity, which you might already know, but I'm recording it so you can view it later if you want. So you'll either want to coordinate like what scenes you're working on, or you can duplicate a scene. Wrong thing again. You can duplicate a scene. You can right click and it won't show it here, but you can just press like Control D and it'll make a new one. You can name it your name, like Shronic scene. You can do your changes there and then copy them back over to the main scene later. It's up to you. So now going into what a scene is, like, so Unity is not that complicated once you know the following. Everything in the scene is in the hierarchy, which is on the left side here. And so we have an object. You can have objects nested within objects. So this freshman dorm scene has this exit button inside of it, and I can move the exit button around manually. Or because it is a child of the freshman dorm scene, I can move the freshman dorm scene around, and the button scene will follow it. So a child like uses the local core space of its parent. So if you, for say, wanted to like attach an object to your finger, you would find like the finger bone, and then you would attach it. You would put it like underneath the finger bone. So yes, and then everything in the scene is in the hierarchy on the left. Somewhere in this sometimes very complicated nest of objects. It's just like folders in a computer. And then every object has their components on the right, which you find in the inspector. So if we just look at the components on this exit button here, every object will have a transform, which is the position, rotation, and scale. Most objects will have the mesh filter, which shows the mesh that is used, the mesh renderer, which has some whatever. You just need those to see an object. And then this has a box collider, which determines how it will collide with the scene. So for colliders, if you search collider, we have a bunch of options: box collider, capsule collider, collider 3, or not. We have mesh collider. The mesh collider will look at your mesh and it will approximate like a lower polygon version of your mesh for collision, because collision calculations can't have too many polygons for performance reasons. Are you guys like, is this like, am I going too in depth right now? It's like, okay. I'm just kind of like touching like everything. It's really disorganized. If you want me to repeat or like go into anything, just again let me know. So we don't see any like logic on this exit button. There must be logic. So let's look at what the childs of it are. I believe Shronic, did you make this exit button? Oh, Timothy. Okay. So if we look at the child of this exit button, we have this sphere sitting on top. Just a primitive object, but that's all right. Sphere, mesh renderer, sphere collider. So now we have a script on here. So you can make a script on any object by clicking add component and type script. And you can say new script. You can write it and just, select, put it there. Scripts also live in the scripts folder, just for organization. We only have 4 custom scripts right now, which means the project is pretty simple. But yes. So if we go back to the sphere, we see this exit button script. We can click the 3 dots and click edit script. And it can open in your text editor of choice. I think I usually use VS Code, but this is Visual Studio. So jumping into a little bit of basic Unity C# scripting. It's not that bad. I think most of you probably know Java. It's pretty similar. It's just some type of object-oriented language like that. But there is a couple unique things to the Unity, So it'll usually auto-import these. It says using instead of import. And then class, and it's a mono behavior, which just means it's a single script. So here's we declare all our variables that we're going to be using at the top. So serialized field, private game object, left index. So here's a Unity specific thing. You can type these brackets with serialized field in front of any declared variable, and it will make it visible inside of your component here, which is really helpful. So for instance, I want to reference a game object in the scene. Because this script is not only ever going to be used in this scene, I have to actually drag and drop that object reference into this box here. So I kind of have to serialize it so that I can drag a reference into this game object in the scene. And that, you don't have to do it that way. You can use tags or search for objects of class in the scene or something, but that's more difficult.
What's the benefit of making it private and just serializing the field instead of making it public?
I believe even if you make it public, let's do a test here. So we have the left index finger.
So I know if you make it public, it will show up by the way in the inspector. Right?
Oh, is that true?
I think so.
I do Unreal Engine now, so it's been a while. Yeah. So yeah, if you remove serialized field, you see that left index is no longer visible here. But now let's do a test. Let's still make it serialized, or remove serialized, but make it public. See what happens. Ooh. I am on a remote desktop, and I'm not using an IDE that I'm used to. Make sure it's saved. Recompiling. You should see this if you change it.
Yeah.
Okay, so yeah, it still shows up. So I guess the benefit is that you probably know in object-oriented classes, you don't want to make every variable public because you probably don't want to reference it in every other script in the game, and it's usually simpler if you just leave it private. So yeah, does that help?
Yeah.
Cool.
So just making it public, make it accessible to other
Yeah.
C# scripts.
If you make it public, it means this variable can be referenced by any script in the game.
Got it.
So we're referencing left index. So if you click on it, it'll show you in the hierarchy where it is. And this looks super complicated because the human body is super complicated. And that is unfortunately what we have to deal with. So let's jump over to the camera rig really quick now that we're looking at the camera rig. So in every scene, we'll have this camera rig. This is so disorganized, I'm sorry. But real quick, the Unity plugin that we're using, there's this really fun Unity button in the corner, and you want to click this frequently because it'll tell you project setup tool, there's one outstanding recommended fix, and it'll say some shit and you click apply all, and then it'll be like, okay, cool. And you might have to do this like whenever you open the project. And it's saying something about how there's two versions that aren't the same. But we might do an SDK upgrade to this, but I don't know if that's necessary. We would if it would make the project simpler. But so the Meta SDK does do stuff to try to make it simpler for you. So there's this building blocks. You can click here. Is this big enough? Do you want me to make it like larger scale, or can you see it well? Good. Okay. So we have these like building blocks from the Meta SDK, and you can basically just like click any of these, and it will put them into your scene for whatever you might want to use. Camera rig is pretty much required. Pass through if you want to use that. Room model, eye gaze, all this stuff. Controller tracking, hand tracking. Different types of interactions, so you can grab interaction, distance grab. Just stuff in here. Cool. So they try to make it kind of simple. It's not like as simple as it could be because there's still a lot of new features that don't really work like that, or they don't. It's like if you want to use two specific new features together, it's like impossible to get them because they like require specific versions of Unity and they don't. Meta sucks, but it's okay. So for right now, going back to our scene, let's go through this XR camera rig here. You can see it says building block because it was created with this building block. So just looking through it really quick, just to get a feel. Tracking space. We have the left eye, center eye, right eye anchor. You can actually see in the bottom right here the camera feed of that. It starts in the floor, which is like the origin. But when you put your headset on, it'll be like 5 or so feet in the air. So just in case you want to reference like where the eye is located, left eye, right eye, and then the center eye is just like dead center, which can be useful as well. We have our hand anchors, left hand anchor. So this app supports controllers and hand tracking. So you can actually start with your controllers and then you can set them down and then you look at your hands and it will start hand tracking. And it works at runtime. You can pick up your controllers again and that while the app is running and it just works. Really cool stuff. I believe this project is mostly designed around hand tracking input though, because I felt like that is more accessible to non-VR users. Yep. So we have those anchors if you want to reference those. We have this interaction folder. We have this HMD. We have hand tracking. So everything under this hand tracking is where the. So we can see in the origin here we have all these models like inside of each other, and you can see the hand models for hand tracking, and you can see the various Oculus controller models, and it will just choose whichever one you're using.
Did you have to manually include all of these building blocks, or was it all just part of the camera rig?
I think you'll first like add the camera rig, and then I probably added in the hand tracking and the controller tracking, and it just put them into there. Okay. It just knew where it was and just plopped it in. So if we look synthetic left hand, we have all of this skeleton stuff. Little complicated, but if you click on them, you can see where they're located. So we have left index finger pad marker, which could be useful, fingertip marker. Let's get a better view of that. Right here. Fingertip, finger pad right here. If you want to have like a touch interaction. All this stuff. But if you think about like how a skeleton like a skeleton works, we'll have like the base bone and then the second bone here will be a child of that, and then the tip bone will be a child of that. And so that's kind of how skeletons are constructed in video games, and usually it'll be like the chest bone is the origin, and then like your spine and everything apart, like down that and up that will like, you know, be children of that. But we don't have that. We just have hands and head. So we have all this shit. So there's that. Let's close that so we stop being stressed out by it. Sound good? Sweet. And then we have these other building blocks, left poke and left grab. So these allow for these interactions. So they have a built-in poking interaction and a built-in grabbing interaction. I found that their poke interaction is so bad that I just did it myself. But it's really simple. I can show you. Oh yeah, and that's actually like the script that we were looking at. So hopefully you get, that's the camera rig. Hopefully that makes a little bit of sense. So coming back to this script, we instantiated these variables that we're referencing. So let's go back to this. Where are we? Freshman dorm scene, sphere. So we have left index finger, right index finger, left controller index finger, right controller index finger, because we have to support both. And then we have these distance variables for each. And then here we define how close of a distance we want to be to the button before it selects, and this is 0.1 meters. So the default unit is meters. Humans are about 1.8 meters tall or 2 meters. So a meter is like this tall, and then a centimeter is like a tenth of that. So scene name. So I just referenced that by name. That's a text field, and then we have our camera rig that we're referencing here. So you can see this is the game object little symbol. So I want to just drag and drop this. It works probably. I'm not gonna do that. No, never mind. We're gonna redo that. And then you can also like push that button and like search for it, I guess. Going back to the script, that's where we instantiated those. And then this is pretty simple, just on update. So left index distance is vector3 distance, so the distance between this dot transform dot position. So this meaning the button, which is me, which is the parent of the script. And then the distance between me and this left index variable dot transform dot position. So on update, which means every frame, we get the distance of these 4 index fingers, and then if any of them are less than the select distance, we do scene manager dot load scene name, which just does so because it's main menu. So if we click the button, or if our finger gets within a centimeter of the button, we load the main menu scene. Pretty simple, right? Cool. Another idea is because it's just like an instant like teleport, like a scene loading. It would be interesting to have. It would be interesting. It would be interesting to have maybe a fun transition animation. Like I'm like materializing into this scene or something. So maybe that would be interesting if one of you are interested in working on that. How you guys feeling?
Good.
Is this making sense? Yeah.
Why does the distance for interaction have to be a centimeter? Can't it just be like 0 when you touch it? Or is that silly?
So it's just the origin of the object. So
like the center would
yeah. Yeah. So it's just the location of the sphere is just the center point of the sphere. So we're not taking into account like the size of the object.
Yeah.
So
So for different size objects, it would have to be different sizes of interaction.
yeah. So this is just one like hack. Very often in game development, it's really easy to just get distance, like if I'm less than distance, because when you're inside of a certain distance, that just math says that creates a sphere. So if you wanted, and that's also pretty easy to compute. Like it's very optimized performance-wise. Even more optimized if you do distance squared, because the distance formula is like x squared plus y squared all square root plus z, whatever, if you're in third dimension. But the square root is not, is like an O of n operation for a computer. So you can remove the square root and then just like take the square of the distance that you want. And so then it could be like 0.1 centimeters squared. That like,
Okay, yeah.
this is all like, I work on a multiplayer VR shooter, so it's all stuff that like you have to think about, but it's really not that big of a deal. So that's just a distance thing, but you don't have to do just distance calculation. You can do collider. You can use the collider. So you can say like, just for example, if I wanted to like touch this title here, we use a mesh collider. I don't think you could show it, so I'm actually going to remove this. But you can do like a box collider on this, and then if you click edit collider, it very nicely, very graciously made it look good. But if you need to edit the mesh collider, you can like click edit, and then you can drag these bounds in and out here. And because like collision is usually an approximation like this, so you could make it be like, oh, if I collision event, if I collide with this box collider, then do something. Does that make sense?
Mm-hmm.
Sweet. Cool. So yeah. I think we're doing pretty good on time. I'll just go through an object. Oh yeah, well, so for this, we have the same thing for this, this poke cube here, freshman poke cube. So when you poke it, it teleports you to the scene. Same thing, finger distance event handler. But I think this one is different because we also have a little bit of additional logic on this. So if you're within a certain distance, we have hover distance, which is a centimeter, and select distance, which is 2 millimeters. So if you get within the hover distance, it will change its color from yellow to white to indicate that it'll change its material from this yellow material to this white material, because that's pretty simple. To indicate that you're like a bit about to interact with it, and then when you get even closer, then it will perform the action.
Does it do it automatically, or do you have to like press the trigger?
This is just based on hand tracking with the location of your finger bone.
So just as soon as you get close, it'll automatically take you?
Yeah.
Okay.
And so we set this material to white, and we also say infocard.setActive true. So this info card, if we play, I'm gonna take a nap real quick. Okay. Oh shit, it's launching Steam VR. Okay, this is fucked. Okay, never mind. Never mind. We're gonna ignore that. And my like five add-ons. Oh my god, leave me alone. Okay, so we have this, you can't click on this info card for some reason, but if we go to freshman poke cube and then map info card canvas, that's this right here, and you can move it with that. Oh, also, fun little keyboard shortcuts. Q or E or W, sorry, W means move, and you can move along 2 axes at once by selecting the square. I don't know how easy it is to see. Yeah. Or you can move on 1 axis, or you can just on a normal transform thing, you can edit this value directly, or you can drag on this value as well. And then, so that's W is move, E is rotate, so we can do that. R is scale. We have all these up here as well. You can scale on 1 axis. So if you wanted to make this, you could just add a default cube and then scale it. And then T is rectangle tool, which I think is pretty useful because it gives you some other options like this. And it changes based on the axis, like the direction you're looking at it from. So if I look at it from the top, it'll change to be like the whatever that is. And then we have Y, which is my favorite because it is every one combined. So you can do anything you want with that. How fun. What was I saying? Right, so this info card, this is provided by the Meta SDK, so it's kind of nice. And I believe part of the reason why it's nice is because if we edit this, find where to edit this text, and I just like type other stuff, it actually like changes the size to adapt to this amount of text, which is really cool. That is given because Unity is pretty bare bones, and Unity hates you and you have to do everything by yourself. Cool. So, there's more meta stuff. So, this is the default skybox, but this does use pass-through. How? I'm not sure. Because I said so, I think, actually. So like when you experience this in the game, like you won't see the default skybox, but you'll see the room that you're sitting in.
And the building block that says pass-through.
Yeah.
Which is included.
I think I did that. So a little bit more about the Meta SDK. We can just click on this camera rig, which is kind of like the center of everything. We have all these building blocks here. Camera rig stuff. So this OVR manager script is kind of important because it'll like do some like configuration stuff. So we have these boxes checked, so it supports Quest 2, Quest Pro, and Quest 3. We have some other options here which we don't really touch. Tracking origin type. Most of the time you'll select floor level because you want it to align with like the floor, and you don't want it to be like inside of the floor if like someone is shorter than you and you didn't account for that. Eye level. So, but sometimes, let's say you have like a mixed reality game where you just have something floating in front of you, then it doesn't matter if it's floor level, you want it to be in front of you, so you can do that. You can have the origin be based off of like your eye location. Simultaneous hands and controller, awesome, that's new. Wide motion mode, hand poses enabled, this is for specific. These are like some new features that you can play with. So we support controllers and hands in this project. Other stuff, tracked keyword support, we don't use that. Pass-through support required. So when you first open the project, I think it'll prompt you if you want to allow pass-through. Body tracking, face tracking, eye tracking, we don't use any of that. We have the splash screen here, so we have this image that shows up when you launch the project. Enable pass-through is enabled right here. Other settings, which don't matter. But that's a little bit more of the vibe for Meta SDK. Cool. We have the Meta SDK docs. If you just search Meta Interaction SDK, you can find it. So if you want to learn anything, about specific things, this is a good place to go. They tell you about like a good handful of the interactions that they provide. Pretty cool stuff. There's multiple types of hand grabbing. So we have to manually set up the hand poses for the objects to have a good experience. You can see you can grab objects, but they can be locked to an axis. Really cool stuff. You can hear sound effects. That's locked by rotation. That disappears your hand when you pick it up. There's UI elements. This is where you see the box at the bottom is where I got the tablet from. Yay. We love interaction. This is the future, guys. You're building the future right now.
Can you do that directly? Like while you're inside? Like with the headset on, or do you have to do that outside of it?
Yeah, wait, do what? Like set up the hand poses?
Like, can you edit the game within the game using those interactions? Like, can you apply
Oh.
That'd be interesting.
I wish, man.
That'd be a lot
I wish.
easier.
I hope that's the future. But as it is, no. But like there is a workflow where it can be for the VR development. It can be really convenient to use a virtual monitor in your headset, so that you don't have to like take your headset on and off like every 5 seconds if you're trying to test something. So there's a lot of super cool interactions. Hopefully this inspires a little bit. So this touch grab, you don't have to set up the hand poses. You don't have to like manually create the hand poses. It'll just snap to whatever position your fingers are in, but it can be a little weird, especially with controller hands. And this is with a trigger and a trigger interaction. So like let's say you want to learn about some of this. You can look through here. Let's look through here. We say features, poking objects, poke interactions. Boom. Easy mode. Actually, it's not easy. This is horrible. I hate this so much. That's why I did my own script. But grabbing's pretty fun. Oh yeah, so the synthetic hand, the reason, I don't know if you saw we had a synthetic hand. That means that the virtual hand model can not be, it can do something other than what the skeleton tells it to do. So like if you're grabbing an object and your real hand is clenched like this, but your virtual hand is like locked to the object, your real finger bones and your virtual finger bones won't line up. And so the synthetic hand enables that to happen. Also, let's say if you're pushing a button, your finger can stop on the button virtually, but in real life your hand might like keep going a little bit. But seeing your hand stop on the virtual button helps a ton for like it's this like a kinesthetic like sense, like it makes sense like interaction wise. It makes things feel like more real. However, the documentation is not great. So I think the better way to learn how to use things is to go into this samples folder, and they have example scenes for everything, which is fantastic. So you can open any of these, and they have what you just saw. You can also download this sample project directly from the Quest store if you want to have an easier time experimenting with these different interaction methods. But you can try these in your headset. They have this panel here where you can scene load between all these different scenes. You can click on anything and see how it works. So button panel, I don't know how this works. Touch grab, pointable Unity event wrapper, when released, play audio, trigger scene load. So like Unity is not horrible to learn, because if you want to know how something works, everything lives on the left and everything that it does lives on the right. Like it won't do anything that you can't see on the right side of the screen here, if that makes sense. And so you can, it might take a while to to figure out how to set it up, but you can at least, like, I can click on this object, it'll select the mesh, but I can go up to the parent object, has this grabbable script on it, has this snap interactor script on it. You can see what the parameters are in here, and then you can like go into the camera rig here and see like what interaction it has on there, and you can just kind of copy what's in the scene, and hopefully it works. Cool. And you can see why, if you don't have a headset to work with, it's like impossible to make progress because you won't be able to know. They do have a simulator, Oculus like Meta XR simulator, activate. Let's see if this works. So if I click play, hopefully it won't launch Steam VR. Oh, it worked. So don't read anything. So like this is like a flat screen control. The controls are kind of weird. I don't know why you want to do like some like fighter pilot yaw, but like oh, you can hold your controllers and do data forwarding now in flat screen. That's so cool. Like you can use your real life controllers even though you're not wearing your headset, and it'll.
Oh.
Yeah. But like what do we want to do here? I don't want controllers, so maybe let's say.
Interactive model shapes.
Where is that?
No, just like.
Oh yeah, I want to see if I can do. If we do both eyes, we can see that. If you cross your eyes, then you can get like a 3D effect. Oh yeah, connected controllers, left, right. No, that just disabled it. I don't. Oh wait, here we go. Hand, no, I don't know. You can probably figure it out. I haven't messed with this that much, but yeah, at least you can use it. So like you can, if you really want to, if you don't have a headset, you're in a pinch, you want to try grabbing something, you can like figure out it's like left click or something. You'll have to like, it's probably on the documentation like what the input is. But yeah, any questions? I'll keep going. We got time. Let me walk you through building really quick. So, building to the headset, which you'll do 90% of the time. If you have a Mac, you have to build to the headset. If you have a Windows computer, you can technically stream it to your headset, which can save you a little bit of time, but is also a pain in the ass sometimes. So if we go back to our main scene, if we go like File, Open Recent Scene, Main Menu. So step 1, building. Go to Meta button, Project Setup Tool, Apply All. Because a lot of times, it'll be like 11 p.m., I'm like tired, and I'm like, this is not working. And then I wake up in the morning and I'm like, oh, I forgot to hit the button, and that's why it wasn't working. So.
The fix all button?
Yeah.
Okay.
Apply all button, fix all. Number 1, do that. Number 2, go to edit. No. Go to File, Build Settings. I like to dock mine up here. If you're on Windows platform, you're going to want to go click on Android and click Switch Platform, this Switch Platform button. It might take 5 minutes or so because it has to like recompile everything for this target. You don't have to touch this stuff. It should automatically set it for you. And then you're going to want to plug in your headset. Plug in your headset via USB. Click Refresh here to update the USB devices. You should see your headset like as an option here. You'll select it. And then you just click Build and Run. And you can't just click Build. You have to click Build and Run. And when it runs, it will transfer the project to your headset over USB. And if you do that, it'll ask for where you want to put the build. It doesn't really matter. I just throw it in the builds folder, build 1, and I like overwrite it every time. But you just do that, and hopefully it works, and it might take a couple minutes or longer, but over subsequent builds, it will hopefully take less time because it should only like change what like the difference is between the two projects. Maybe not. Yeah. Do you want to try doing that on your headset and see if it works? Oh yeah.
I'm building to Android right now.
Oh okay, cool. Here's a official Questlink cable, which I know works.
Okay.
It's mine, but it's USB 3. You don't need USB 3 for building to the headset. You can do it over USB 2, but it'll be 10 times slower. 10 to 20 times slower. So, yes.
On Mac, do you also build to Android?
Mm-hmm.
Okay.
That's you have to build to Android because there's no computer runtime.
When are you building to Android? Do you just do that?
Oh, whenever you want to test it.
Oh, okay.
Yeah, anytime you want to test your work in the headset, that's when you do it.
And then when you edit it, you just go back to the Mac platform?
No, you leave it in Android all the time. You don't want to waste time. You don't have. So this platform is just for building, like building the project, like packaging it into an app that someone can open, like somewhere else. So we're not building for Mac, so you can just leave it in on the Android platform all the time, and it'll still work as when you like run an editor. Yeah. Cool.
I got a question real quick.
Yeah.
So I figured out to switch into dev mode, you need to like pair it with your phone.
Yeah.
However, it can only like support one phone at a time.
Yeah.
For some reason, so I have to factory reset it.
Yeah, you can do that.
Okay, because I was kind of afraid of factory resetting
Yeah.
anything without asking first.
Yeah, I don't think Sydney did anything. Sydney was logged in and she's
Yeah.
not.
Okay, I'll do that real quick.
Cool. I don't know. That might take a while, but your homework is to make it work.
Got it.
Any questions about what I talked about? Do you guys feel good about like trying to like learning this stuff, or do you feel like really scared? Like, let's do a thumbs.
Put me at a 6.5, 7.
Like halfway. Pretty good.
But
Okay. That's cool.
That's Unity.
Yeah.
It finished building to Android.
Sweet. Yeah, I don't think you'd be able to build to that headset without developer mode.
Okay.
But
How long do you think the factory reset would take?
a while. I don't know. Factory resetting a whole set sounds. You could try it now though, if you
Okay.
want. Yeah, it's complicated, but it's all right. So last year I did a second workshop about going more in depth about specific things like creating hand poses for objects. I think Shrenik might honestly know a little bit more about me than that at this point.
It's not that complicated, so if anyone wants to know how to do it, I can just teach you like 5-10 minutes.
Okay. Real quick, I guess where we are scenes, just the standard format right now for all of our objects. Let's just go to this ramen right here. I have to keep clicking until it gives me what I want. Ramen pack. So it has a box collider, rigid body, grabbable script, physics grabbable script, hand grab interactable. You need all this. It's horrible, but you need all of it. Because there's like multiple types. There's touch grab and there's hand grab, and we're using hand grab right now. And this is where you put in the hand pose, and if you click on this in the hierarchy, you can actually see it. So ramen pack left hand, you can see this hand pose. So this is what your hand will snap to when you pick it up. And then we need to do that for the right hand as well. So we have that. And then this doesn't do anything. So we're going to minimize that. We have this respawn on drop script, which is really simple. It just takes the location that it spawned at, and every frame, if the location is 0.2 meters below that, it'll teleport it back to where it started. So if you drop something on the floor, it'll just respawn where it was, so you don't like lose it. And then finally we have this pointable Unity event wrapper script, which is built in. So when the object is selected, so this when select is tied to the grab event. So when it's selected, we reference this info card. You'll do set active, which hits that check button, and it'll make it visible. So when you grab it, you'll see the info about it, and when you let go of it, the info will disappear. And so that's all we have on the object. If you want to, like, on select, you can add another thing here and be like, play a sound effect or something. And then for this info card canvas, we have a custom script here called slow look at and move, which is pretty simple. You have to put in the sign transform. So the ramen pack, its children are left hand grab, right hand grab, geometry. I don't know what that's for. And sign transform. So this is just an empty thing. You can right click, you can say create empty. So this transform is just the position that we want the panel to be in relative to the ramen. So in the info card canvas, we reference the sign transform and we have a speed variable, but all it does is look. So okay. So it just knows the main camera variable, I guess, from the scene. The two other variables here. Oh yeah, so main camera equals camera.main on start, and then on update, transform.look at main camera, and then transform.rotate 180 degrees on the y-axis because it was like offset by that. And then the position, we set the position to move towards the transform of the target transform with this speed. So it won't instantly, like if you move the ramen around really fast, it'll like lag behind the ramen, and it just kind of makes it feel a little bit more like natural, I guess. And if you increase the speed value, it will move towards the ramen faster. The script is pretty simple too, it's only 20 lines, but that's kind of what our project is made up of right now. It's just these simple interactions with a bunch of grabbable props in this scene, and it's all, photogrammetry props. Not all photogrammetry. I stole this model from the Meta website, and I stole these models from the Apple website. Official AirPods right here. And it can be that's a whole nother workflow of like importing 3D models and editing photogrammetry and stuff in Blender, and that's a little more complicated, but this is at least it from the Unity side. Hopefully it doesn't seem that complicated. I know that you guys can figure it out. You just have to, it's a lot of game dev is a lot of problem solving and creativity with that. Any final questions? We're at an hour, so I think I should let you guys go. Any final questions? Yeah.
Did you guys make the map like manually in the previous semester?
No. We found it. I don't remember exactly where we got it from. I think we got it from. I had like another job. I think there's something on campus called the Imagine Lab. And they provide like 3D models of things on campus. Or I actually think this was like, there's like a Google Maps API that lets you export a 3D model of a specific like. To get to clean it up and make and like have it so like everything's labeled. So we have power lines, rails, roads, all this stuff, and I just assigned colors to them so they look decent. Yeah. Is there anything specifically that you guys might want me to go over if we were to do another workshop, like go more in depth into a specific topic? You can think about it and maybe message me later. I think that's for I'm gonna stop the recording now, and I'm gonna upload it pretty soon, hopefully.